this module, this presentation is based on its 4 sequences strings in this module. And a sequence is described as an ordered list of items, either in decreasing order or increasing order. Hello?
Hello.
Yeah. Did you hear me?
Yes, but maybe you have to speak up a little bit.
Okay.
Yeah.
So this presentation is based on Unit 4 sequences and strings on the Mathematical Foundations module. And a sequence is described as a list, usually numbers, which is laid out.
Wait, can you make sure that we all mute our mic? Also, let's make sure that we turn off our cameras. Thank you. You can actually proceed.
Okay. So a sequences are ordered lists of items. It's an ordered list of items, usually in numbers. And they are infinite. And here in this presentation is defined as a sequence. Is defined as a function which comes from subset n to a set n. And we use the notation an to denote the image of the integer, which we call the n term of a sequence. So here we have 1, 2, 3, 5, and 8, which is a sequence which has 5 terms. And this sequence is described as the special type of function. And the sequence presented here is a finite sequence which has a limited number of terms. And if it was an infinite sequence, the last term of the sequence would not be defined, and the first term would be the one which will be defined in the infinite sequence. So the sequence presented here is a finite sequence, which is the first and the last term. You move on to the next slide. Hello?
Yes.
So okay.
I think if you speak up like what you have done when you say hello, I think it will be good for us.
Okay.
Yeah.
So in this slide, types of sequences, we have 2 types of sequences, and those are the increasing sequence and the decreasing sequence. And the sequence S is increasing if Sn is less than equal to Sn plus 1 for all n terms. And it is decreasing for all Sn greater than or equal to Sn plus 1 for all n terms.
Yeah, maybe for addition here, just to clarify things. When I say Sn is less than or equal to Sn plus 1, if we have got a sequence with maybe 1, 2, 3 as its what? As its elements. This one will be at index, maybe let's say it's 0, 1, 2, right? So if this one is our Sn, this one will be our Sn plus 1. If this one is our Sn, this one will be our Sn plus 1. So for it to be an increasing function, it means that the previous value must be always less than the next value. If it is a decreasing function, it will be the vice versa. This one will be always greater than the next value, something like that. I think you can actually proceed.
Okay. So in the next slide, objective sequences and strings. sequences, they represent an ordered list of elements. So in order for a list of elements to be defined as a sequence, they have to be in a particular order. See if I'm opening the correct slide.
May you please raise your voice?
I think
May you please
my
raise your voice?
microphone.
I don't think it's your
my
microphone. It's like you are moving away from it, or I don't know what's happening.
It's on my mouth. I think my microphone is got a problem.
Okay.
Okay, so here we have the arithmetic sequence, which is formed by, which has the formula an is equal to a plus dn. An being the term, and a being the initial term, and d being the common difference, and n in the formula being the term number. So here we see, so here to find the first terms of the first 5 terms of an, which is there on the slide, we let a equal to 5 and the common difference be equal to 2. So if we want to find maybe the second term, we put 5 as the first term, common difference we put, and then we put 2 as the common difference, and then we put the term number 2 to replace n, calculate the second term of the sequence. Hello, are you still there?
Yes, we are here.
Okay. So basically we have the arithmetic sequence and the geometric sequence. And in the geometric sequence, the sequence is formed by multiplying the initial term a by the common ratio to the nth power. And in that formula, an is called, in the formula an is called to a to the power rn, a being the nth term being defined. Hello? Hello?
Hello, just wait. There's someone who have got actually switched on his mic. I'm just trying to find the person. Can we all make sure that we mute our mic and also turn off our cameras, please? Okay.
After the
You can
arithmetic
proceed.
okay. After the arithmetic sequence, we have the geometric sequence, which is formed by multiplying the initial term by the common ratio to the nth power. In short, the formula Hello?
Hello, you can proceed.
Okay. So after this slide, we'll move on to the geometric sequence. Here, geometric sequence is formed by multiplying the initial term, which is a, by the common ratio to the nth by the common ratio, and then we raise that to the power r. So, so here in this formula, we get the initial term. It says not to find the nth term of the formula, we let a equal to 4 and r equal to 3, so that we can find the first 5 terms of the geometric progression. So we say a times, so we say an is equal to 4 times common ratio r to the power n. So we want to find 5 terms, which is raise that to the power 5. Hello?
Hello, just proceed.
Okay. Anything else to add?
I think you didn't actually done well on preparing this slide. Just to show clearly the steps and the examples on how do you substitute all those things. I think it's something that you were supposed to work on. Okay, anyway, on GP, geometric progression, what you have is a formula here to find the nth term, right? To find the an or the nth term, where our a here is our first term and our r is our common ratio. And how do you find that common ratio? Because it's not always the case where you'll be actually having the common ratio. So these are the things that I wanted you to mention. You can find the common ratio by dividing this one by this one, this one by this one. You get your common ratio. And then you use that common ratio with the first term, and then you raise to the power n. You raise r or the common ratio to the power n, where your n is the actual term that you want to find. Maybe its position, like you want to find the first term, or is it the second term or the third term? If it is the third term, you put a 3 here. So it's a matter of substitution after you have your r, your a, and your n. Also, there is a formula for summation of GP. I don't know if you have actually included it here. It's not here. I don't see it anyway. I think those two things are the ones that we need for this module. You must be able to actually apply this formula and the other one for the summation up to n, for the summation of geometric sequence or geometric just a geometric sequence. So like here, I think here it's an example for you to find the first 5 terms of the geometric progression. If you see here, you are given your 4 as your a or as your first term, and then your r of the common ratio here is 3. So if you want the first term, you only have to put a 1 here. For n, you have to put a 1 here for n, which will be 4 times 3 to the power 1. And then what does it give you? If you say 3 to the power 1 times this one, it will be 12, right? And then you go on to find the next term. here up to, you put a 2 here, 4 by 3 to the power 2, just going on as that. So it will be 3 squared, 9, and then 9 times 4. What do you get there? I think it's a what? Is it a 36 or so? Then you go on to just like that until you get to the 5th term. Don't know if there is any question.
No questions.
Okay. So I think you can actually proceed with the presentation.
Okay. So the next slide will strings.
Before strings, I think there's this issue of summation.
Okay, summation.
Yes, there's this issue of summation in sequences. If you are being asked to find maybe the sum of a sequence, what do you do?
Summation of a sequence. We use the summation formula. In the formula, n denotes the number of terms, and I denotes the position of which each element, of where the element is. And the other operation that we have with the multiplication
Are you still there?
Yeah, I'm still there. We add all the terms. Hello?
The floor is yours. Hey, Tapiwa, you can speak. I saw your hand there.
All right, can you hear me?
Yes.
Yeah, yes.
All right, I wanted to help a bit on the sum and product of terms.
It's fine, you can come in.
All right, so as we can see on the first statement below the definition 4.3a, we have the summation of those terms. And on top, where it's highlighted in red, there's an n there. That n is the upper limit. And then below the summation symbol, that I is equal to m, that would be the lower limit. So when we go to example 4.3a, the summation, the upper limit will be 3. Can you just highlight there, say, on the 3 above the summation symbol? Exactly. So that would be the upper limit for that. And the lower limit will be 1. So when we are doing summation, we'll be adding those terms. We want to find the result if we add those terms, with the limits being the lower limit 1 and the upper limit 3. So we started the first one being with the one with a 1 over there, and the second one with a 2, and the third one with a 3. So meaning to say the first term will be 2, and the second one 4, and the third one 6. And then when you add them, since it's a summation, you get to 12. And then moving on to, and I also stand to be corrected, then moving on to the product of terms, we have the limits as well. the one that has been highlighted, but they say just now is the lower limit, the one on the below the product sign over there. And then the one on top, the 3, is the upper limit as well. So on product, we'll be multiplying the terms, and we want to get the resultant of multiplying the terms. So the first term will be a 2, the second one a 4, and then the third one a 3. And then when we multiply all those terms, we get to 48, excuse me. Thank you. I think that's all I had to say.
Thank you for that. I think you've actually nailed it. You've actually nailed it. Yep. Just know that when I just adding these sequences, what you need is just the lower limit and the upper limit. Where are you going to start? Maybe you are being asked to find the sum of the sequence, maybe from the 5th term to its 8th term. You just start by taking the 5th term and then you add it with the next term, until you reach the 8th term. So it's just the issue of adding or multiplying those elements within that bound, or within the lower limit and the upper limit. So I think we can move on. Are you still there, David?
Yes. Yes.
Okay.
The next slide, we have strings. Hello?
Hello, have you actually gone through this slide before? It's like you are starting reading it now.
I was not really communicated to about the details of the presenter. This is last minute.
But the slide was sent almost earlier today.
Yeah, everything else before I understood, but strings were still a bit confusing.
It's fine. You can give us what we have, then I will add on it.
Okay. So strings are defined as a sequence of characters. And for an example of a string, we take the word mathematics. Can someone help me explain? Hello?
Hello.
Can someone help me explain strings?
It's fine. Let me help you. But next time, let's make sure that we are well equipped. Okay, on strings, team. I think even in programming, I'm sure you are doing C programming. You've actually heard about a string as a data type in a programming also. Especially, yes. Especially in C programming, a string in C programming normally actually defines the string that we want in this module. I think you have actually seen that in C program, when you're talking of a string, you'll be talking of an array of characters, or just a collection of characters. Just like my name, it's just a collection of characters. You take E, you take Z, you take E, something like that. So when you're talking of a string over a set X, is just a finite is just a finite sequence of elements from X. If you are given a set X with elements maybe A, B, and C, we can create some strings there. The first one will be A, B, C. So it's just a sequence of elements from X. The other one, maybe it will be A, B, C. So since a string is a sequence, order is taken into account. Order is also taken into account. For example, the string BAAC is different from the string AC AB. This one is different from this one. Why? Because in strings we take the note of the order. So AB and BA, these are two different strings, though they have what? Same characters. I'm just trying to write all these things. Then repetition in a string can be specified by superscripts. You can also use the issue of superscript. For example, the string BB AAAC may be written as B squared. It's B squared here. It's a 2 here. It's B squared, not B2. B squared A cubed, then a C. You can actually use the concept of superscript. So the string with no elements is called the null string, or is denoted as this sign, this lambda here. So even in programming, we have got what we call a null string. It's an empty string. It's a string with no elements. So the length of a string, which is actually represented by this sign, is the number of elements in what? I think it's a alpha here in our string. So the length of our string is denoted by the modulus of our string, or the modulus of alpha. So if alpha is equal to AA, BAB, and then beta is equal to A cubed, B to the power 4, then A to the power 32, then the modulus of alpha here, or the length of this string will be equal to 5. Why? You have got 1, 2, 3, 4, 5 elements. So this is why we have got a 5 here. Also, beta, the modulus of beta will be 32. Why 32? Here you've got 3 elements plus these 4 elements to make it what? A 7, and then plus A to the power 32, which means plus 32, which will give you a what? A 39. So if alpha and beta are 2 strings, the string consists of alpha followed by beta written as as alpha. Beta is called the concatenation of alpha and beta. So there's what we call string concatenation. You'll see it mostly later when you're doing object-oriented programming or so, something like that. I don't know in C if you are actually do the string concatenation there, but it is still possible to do it in C programming. When you are talking about string concatenation, is when you actually put together just string A and the string B. For example, the string concatenation of T, which is equal to AAB, and E, which is equal to CABD. So the string concatenation of actually T and E, if you are being asked to find the TE, it's what? It will be AAB, then followed by CABD, something like this. And then if it is ET, you need to know that TE and ET are 2 different strings. I think we have actually talked about this when you are talking about the order. Here, the order is taken into account. So TE is different from ET. So For ET, we start by CABD and then AAB. Don't know who have actually turned on his mic and you are listening from a speaker or something like that. I don't know what's happening. There is a feedback. It's fine, thank you. Is it Willard? Okay. So there's this one where there is T alpha there, T lambda there. I think we've actually said that an empty string is also represented by this symbol. So if you see something like this, you are just saying the now string, let's do string concatenation, a string with a now string, and we know that it will be actually equal to T itself, because this one doesn't have any elements in it. So it will remain AAB. So even if we say a now string, let's concatenate with this T again just from behind, it will be actually always equal to T, and it will be always AAB. Don't know if there is any question here. It's fine. It's look something which is very simple and very easy, and also it's part of your exam. It's also part of your exam, so you need to take it seriously. Even the group that was presenting this topic, the idea of giving you some topics to work on is that when it comes to exam, you'll be actually having an upper hand than the one which was than the one who was not actually in that group. So if you are not actually researching on a topic that I gave you on your group, you'll be actually making a blunder there. Let's make sure that we do well on our topics that we are given. It's very important. You see it when you're in an exam. When you fail to actually collect full marks on something that you're actually given to work on, maybe for more than a month or so. So here's the end of this presentation. It was only on the sequence and the strings. And I think on arithmetic progression on this slide, it wasn't actually well listed. I think you need to do more on this arithmetic progression and the GP and the geometric sequence. Just do the formula to find the nth term as well as to find the summation of the nth term. I think that's all on this topic. I don't know if there are any questions or any contributions.
Ndaida kubvunza kuti paYouTube this broadcasting the broadcast inenge iripo by when, because the first part now tanisiri kunzwa kuti zvinazvinzwide.
I will share it maybe just now or so, but definitely today.
All right, thank you, sir.
Okay. Mukoni. I mean, is it Mukono or so? Some Mukondo. There's a hand there. You can actually contribute. Mukondo, you can unmute yourself. Is it a hand?
Hello,
Okay.
sir.
Hello.
Yes, sir. And
So
I just
it's okay. It's okay.
Okay. I want to be part of my group, but as of now, I don't know the other members of my group, like what you have been told me on the group WhatsApp group, that I could choose from group 6 or 7, but up to now, no other member can talk to me for the presentation you have been given to us.
It's fine. I will try to find the group leaders of all those groups, of all the remaining groups, so that they can actually engage you. I will try to find their contacts.
Okay, sir. Thank you.
Okay, Ngoni Dash. Is it a end? You can
Yes,
speak
it is.
if you have something to share. It's okay.
It's just a question. Say it might not be relevant, but just on strings.
Okay.
When you mentioned the issue of order, so I think from the programming module, I understand
Yes.
that each character from an ASCII point of view is mapped to a certain value. So arithmetically, the order, the manga mchitaura, I don't know if it applies, but the order manga mchitaura, does it then affect it from an arithmetic point of view? It's just the string representation.
It's a string representation. Just imagine if your name, if you take the letters on your name, right? And
Yes.
then we just put it randomly. Is it still your name?
No, from that configuration it's not my name.
Exactly. So this is what we are talking about in strings. Order do matter.
Okay. But this is nothing to do. This has nothing to do with the underlying values of a given character.
Yes, of course. Why do we need to actually perform the arithmetic part? I don't know the aspect. Why do we need the arithmetic part there?
Okay.
Just want to know why do we need the arithmetic part? Because look here on this one, on this module, the most part that we are preparing you is just for normally using all these things in programming. That's why you are going to use all these things. And in programming, when you are doing string concatenation, maybe you want to manipulate a certain data, right?
Mm-hmm.
So you need to know the order of your data. If you manipulate it, the result that you are going to get it will be actually different from the other one. Even in a word processing or even in a text editor or what, the string will remain different. If you actually change the positions of the elements or of the characters, it doesn't matter if the arithmetic value, if you add them or if you multiply or do what, does it matter? Or if it is going to give us the different value or the same value.
So my main reason for asking was just to draw that distinction, because I know there is utility in also just working with the arithmetic value, probably from a comparison point of view, than just working with the character configuration. That's why I was just asking to see whether that's something that's just in the domain of programming and not specific to what we're talking about.
Yeah, something like that.
No, thank you very much, sir.
Okay.
And for that other gentleman, I'm the group leader for group 7.
For group 7?
Yes.
It's fine. You can share your contact in the chat. Maybe you can take that from there.
All right, sir. Thank you.
Okay, or just to inbox me on WhatsApp.
I'll do that just now.
Okay.
Okay, so thank you.
Okay, then we have got Lindo Kuhle. It is still a hand.
Hello, sir.
Hello.
I don't have a group, sir. You can add me anyway.
It's fine. It's fine. Just send a message in our group.
Thank you.
I will look at it later. Tapio, is it a hand?
Yes, it's a hand, sir.
Okay, you can actually contribute.
All right. I wanted to say that when we are multiplying strings, Say,
Yes.
for example, we have two strings A, B, and BC.
Yes.
I just wanted to say it would be different from, say, AB multiplied by CB, something like that. You need to have a matrices background. You have to think like you're working with matrices. When you have, let's say, two matrices which are 4x4 matrices, right? When
Yes.
you change their position, AB is not the same as BA, something like that. When you have a background of matrices, you understand it better. That's all I can say.
Okay, thank you for the contribution. Don't know if there is any hand or someone with something to contribute. So I think we have actually reached to the end of our presentation. So the next group to present, let's work on our slide. I shared a slide that have actually inserted that it's a must read PowerPoint. It's a must read. Why a must read? Because it covers all the elements of that topic in your module. Also, the group who are going to present, may you please accelerate and actually add more on your slide, because maybe I might call you to present maybe tomorrow. Because I'm actually seeing with my schedule, you know that we do not have much time, and we need to cover on propositional logic, we need to cover on the predicates, and a lot more. I think we've got 3 major topics that we need to cover. So maybe we need to do another presentation this week, or maybe 2 more presentations this week. So let's make sure that we polish up everything. So thank you for being part of this presentation.